So in this video, I'm going to give a brief overview of the TCP header. If you want more information, there's of course tons of documentation online, but this is just a brief summary of kind of what the fields in the header and their meaning. A standard TCP header is 20 bytes long. So we can see here that there are 5 rows of 4 octets each. Additionally, you can have options after the TCP header. I'm not going to go into any of those now. The basic TCP header you see in most connections is 20 bytes long. So the first two fields in TCP are the source port and destination port. Each of these are 16 bits or 2 octets. So we talk about connecting to the web port, port 80. That's the destination port, say, of 80. The next two fields are the TCP sequence numbers. So these denote from the source of this packet to its destination what is the sequence number of the data contained in this segment, as well as what is the acknowledgement number from that endpoint. So for example, if I want to acknowledge that I've received up to byte 5000, and then this is sequence number 4000, then as I send, I will send sequence number 4000, acknowledgement number 5000. The sequence number denotes what the sequence number is of the first byte of the data region which follows the segment header. So if I had a sequence number of 4000 and there were 500 bytes of data, then this would mean byte 4000 to 4499. Now the acknowledgement number acknowledges the last byte received plus 1. And so if I were to send this segment 4000 to 4499 and the other side received it, it would send an acknowledgement number of 4500. That is, in TCP, the ACK is not for the last byte received, but that plus 1. What is the next byte that is needed? So when we talk about TCP ACK packets, what these are TCP segments that have no data. All they're doing is counting the acknowledgement numbers for. This happens if, say, traffic is unidirectional. I'm sending lots of data in one direction, but there isn't data coming back. If the flow is bidirectional, then these acknowledgement numbers are just going to be added or padded onto, or not padded, but incorporated into the data segments as they're being sent. So after the sequence number and acknowledgement number, we have a bunch of fields. Let's start with the checksum. So the checksum is computed over the TCP pseudo header, which is the TCP header, as well as some of the IP header. This is a way just to add a little bit of additional resilience for the IP header, like the IP addresses, etc. So the checksum covers this pseudo header, the TCP header, and then the data within the TCP segment. And so the checksum actually in some ways stretches before the packet to this pseudo header filled in from the IP header, and then stretches to the end of the segment. Simple ones complement checksum. The window field is the flow control window. It tells the endpoint, so the flow control window, the window field within a packet, is telling the other endpoint how much received buffer space its sender has. So if you say a window of 20,000, that means that there cannot be more than 20,000 outstanding unacknowledged bytes in this connection, in that direction. So these bits here, U, A, P, R, S, and F, are control bits. So let's start with some of the sort of less common ones. So there's U, which is the urgent bit. That means that this data is particularly urgent. So hey, let's get it to the application quickly. Then there's P, which is the push bit. So the push bit says, hey, please push this data to the receiving application. So the other 4 bits, there's the ACK bit, the reset bit, the SYN bit, and the FIN bit. So the ACK bit here, this bit is set to 1 if the acknowledgement number field is valid. So the ACK bit is generally set to 1 for every single segment except for the first one that initiates a connection. Because when you initiate a connection, you don't know what the other side's sequence number is, so you can't acknowledge anything. So the ACK bit is not set. So when we talk about TCP setup, we'll see that the first packet sent does not have the ACK bit set, but all other packets in the connection through its termination have the ACK bit set. The SYN and FIN bits are used to set up and tear down connections accordingly, or respectively. So the SYN bit says hey, this is my starting sequence number. Please synchronize to this number. And so when you first open a connection, you send a packet with the ACK bit not set, but with the SYN bit set, and then a sequence number. And you're telling the endpoint, I would like to synchronize you to this sequence number, which represents my first byte of data. The other side can then respond and say, all right, I'm going to acknowledge that sequence number and send you one of mine. In this case, both those fields are valid. To which then you can respond and say, okay, I'm going to acknowledge your sequence number. Now we've synchronized. We both know when the bytes start. So one of the things is that you can imagine I could always just start my sequence number at 0 for every connection both directions, but there turn out to be real security problems with doing that. That means people can guess what your sequence number is. They can start interspersing packets. It's generally seen as a bad idea. Also because if you have lots of short-lived connections, these packets with similar sequence numbers can be long-lived in the network, and you want to be able to filter them out. So the F is for fin. This is for tearing down a connection. So when you set the fin bit, you're telling the other side, I have no more data to send. And so often the exchange is you send the fin, they acknowledge the fin, they send later you a fin with no more data to send, and then you acknowledge that fin. The final bit is R, the reset bit, which says, well, you need to reset this connection. Something wrong has gone on. So if the urgent bit is set, then this urgent pointer points where in the segment that urgent data is. Finally, we have the offset field. So the offset field is needed because it's possible for TCP to have options. And you don't know from this header necessarily where the options are. So what the offset tells you is at what offset within this segment does data begin. So if you have options, then the offset tells you the size of those options, and your TCP stack knows to look inside there for options. The options are padded to be 4 bytes, 4 octets wide. So that's the basic TCP header. We have the source and destination ports, the sequence numbers, both for the data and then for the acknowledgements of the data that you've received. The offset field to tell you where data begins, the urgent and push bits for urgent data or data you want to push to the application, the acknowledgement bit indicating the acknowledgement number is valid, the SYN bit for synchronizing the sequence number, the fin bit for tearing down a connection saying that there's no more data to send, the reset bit for resetting a connection, the window for flow control, checksum for making sure that there aren't errors in the data, an urgent pointer for the urgent bit, and then options.